Welcome back to 242 Math. I'm your host Raphael Thompson, and today we'll be exploring the circle for BGCSE Math and looking at circle theorems and questions that deal with the circle that may appear on the BGCSE paper, guys. So this will prepare you for that, especially paper 3, so you know how to attempt such questions. Please answer as best as you can at the beginning, then at the end I will show you the answers so we can go over them so you'd understand exactly what you have to do. And here we go. Number 1, name OC, the line OC. Name AB, the line AB. If OC intersects AB, what can you say about AC and BC on that chord? Answer as best as you could. Then we'll check it at the end. Then you'd understand what we're dealing with. And we move on to number 2. Again, name the line OC, the dotted line OC. Name AB, the line AB. What type of line is it? If OC intersects AB, what can you say about angle BCO and angle ACO? Those two angles where the intersection occurs. What can you say about those angles? Answer as best as you could. The answers will be revealed at the end, so you don't have to worry. Number 3. Name the line AB, name that line AC, and what can you say about AB and AC? Take a guess. You might be correct. Have a go at it, see what you can do, and at the end, the answers will be revealed. And we move on to number 4. O is the center of the circle. Describe the location of angle BOC. Where is it located? Describe the location of angle CAB. Where is that located? What do you notice about angle BOC and angle CAB? And I have 2x in the center and x at the circumference. So tell me about that relationship, guys. And number 5. Describe BEC, that part of the circle, that part of the circumference of the circle. Describe what you call that. Then describe the location of angle BAC. Describe the location of angle BDC. What do you notice about angle BAC and angle BDC? It's given. Just write it out. Number 6. O is the center of the circle again. Describe BOC, the line BOC. Describe the location of angle CAB. Where is it located? What do you notice about angle CAB? You can look at it and give an educated guess. Moving right along. Number 7. Describe the shape ABCD. What can you say about X and Y? Yeah, what sort of shape is it? What do you call it? There's a special name for it, guys, because of how it's drawn. And we move on to number 8. Describe the shape ABC. Again, depending on how it's drawn, you can describe the name of it. The name isn't important. What's important is describe angle Y and then describe angle X. Where is angle Y and where is angle X? What can you say about X and Y? Here we go to number 9. Describe the shape ABCD. You had a shape like it before, so now similar shape. What do you call it? Describe angle Y, where is located. Describe angle X, where is located. What can you say about X and Y, those two angles? And we begin the questions now. Question 1. AB is the diameter of the circle ABC with center O. AD is the tangent to the circle at A. Angle ADC is 55 degrees. Calculate angle BCA, calculate angle ABC, and calculate angle CAD. So use what we did at the beginning. See if you can come up with the value for each angle. So see which one of the theorems apply. Question 2. DE is the tangent at C to the circle ABC with center O. AB is equal to AC is equal to DE. Calculate angle BAC, angle ACB, and angle ACD. And we move on to question 3. AB is the tangent at C to the circle CDE with center O. Calculate angle the X, what's X, what's Y, and what's Z. Each of those would be an angle, so give the value of each angle. So find X, then find Y, and then find Z. And we move on to question 4. In the diagram, O is the center of the circle ABCD. Angle ACD is 62 degrees. Calculate angle ABD, 2 angle AOD, 3 angle ADC, and 4 angle OAD. Calculate those angles. Do it quickly. All of these apply to what you did at the beginning, so just use the concepts from the beginning. You're straight. Question 5. AB is the diameter of the circle ABC with center O. AD is the tangent to the circle at A. Angle ABC is 40 degrees. Calculate angle BAC and angle CAD. Use the 40 and you're straight. And we move on to question 6. Given a circle Y, X, Z with center O, CD is the tangent to the circle at Z. Angle YXZ is 52 degrees. Calculate the value of angle OZY, angle YZD, and angle ZOY. Go ahead, work fast, see if you can get those angles. And we move on to question 7. Given a circle ABCD with center O, ED is the tangent to the circle at D. Angle ACD is 36 degrees. Calculate the value of angle EBD, angle DOA, angle DEB, and angle OAB. 4 angles, see if you can get them all. Got it? Question 8. Given a circle ABC with center O, AT is the secant to the circle. Angle AOB is 100 degrees and angle CBT is 108 degrees. Calculate the size of the angle X, angle Y, and angle Z. Question 9. Given a circle ABCD with center O, angle DOB is 126 degrees. Calculate the value of angle DAB and angle DCB. Go ahead, get it done. Cyclic quadrilateral. And we move on to question 10. Given a circle ABCD with center O, angle OBD is 34 degrees. Calculate the value of X, of Y, and of Z. Don't give up. Now I'm working hard, but this is what you have to do. And we move on to question 11. RS and RT are tangents to the circle STU with center O. Angle SRT is 40 degrees. Calculate the value of angle SUT. Straightforward. 2 tangents drawn to a circle from a point. You had this at the beginning. Got it? Yes, good. And we move on to question 12. RS and RT are tangents to the circle STU with center O. Angle TUS is 72 degrees. What is the size of angle SRT? Again, two tangents drawn from a point to a circle. You should know what to do, guys. And we move to answers. Best part. Here we go. Circle theorem number 1. OC is a radius, AB is a chord, and AB is equal to BC when that happens. So if the radius intersects a chord, then that chord is divided in half. Got it? And number 2. Again, OC is the radius, AB is a tangent, guys, and if OC intersects AB, what can you say about angle BCO and angle ACO? Both of them are right angles, so if a radius intersects a tangent, it intersects it at an angle of 90 degrees at a right angle. So you have to remember that. Got it? Good. Number 3. And where you have two tangents, so AB is a tangent and AC is a tangent drawn from point A. What can you say about AB and AC? AB is equal to AC. Once you have two tangents drawn from a point and they intersect the circle, then those two sides have to be equal. And we move on to number 4. O is the center of the circle. Describe the location. Yeah, the angle is subtended at, BOC is subtended at the center, and CAB is subtended at the circumference. What can you say about angle BOC and angle CAB? Angle BOC is 2 times angle CAB. So the angle at the circumference is twice the angle that's subtended at the angle at the center is twice the angle subtended at the circumference. And we move on to number 5. Describe BC on the circumference. That's called an arc. Describe the location angle BC, the angle subtended at the circumference, and angle BDC is the angle subtended at the circumference also, but as both of them are drawn from the same arc. And if that's the case, then they are equal. So I have X and X. So the angle subtended from an arc, from the same arc, if you have more than two or more angles, they're the same. 6. O is the center of the circle. Describe BOC. BOC is the diameter. It runs through the center. And then angle CAB is the angle subtended at the circumference. Okay, so what do you notice about angle CAB? Yes, it's a right angle. It's equal to 90 degrees. So the angle subtended by a diameter is always 90 degrees. Or from a half circle, the angle subtended from a half circle is 90 degrees. Same thing. Number 7. Describe the shape. It's a cyclic quadrilateral. That's what it's called because it's in a circle, so it has to be a cyclic quadrilateral. What can you say about X and Y? X and Y are supplementary. What that means is that they're equal to 180 degrees, guys. Got it? Good. Once you know that, then it makes your life a lot easier when you get diagrams like this. Cyclic quadrilateral. Opposite angles are supplementary. Opposite angles. And we move on to number 8. Describe the shape. It's a cyclic triangle. It's in a triangle. It's in a circle and it's a triangle. So it's a cyclic triangle. Describe angle Y. Angle between the tangent and the triangle. That's what you call that angle, angle Y. And angle X is the angle in the alternate segment. What can you say about them? They're equal. X is equal to Y. That's a rule you need to learn to make it a lot easier to work problems out. And we move on to number 9. Describe the shape. Yes, again, it's a cyclic quadrilateral. Describe angle Y. It's an exterior angle. And angle X is the interior opposite angle. What can you say about X and Y? Well, they're equal also. So once you know that, this can make your life a lot easier when you're given such diagrams. So the exterior angle is equal to the interior opposite angle. Number 1. Question 1. Here are your answers. So for number 1, BCA is 90 degrees, the angle subtended by the diameter, of course. Angle ABC is 35 and angle CAD is 35. So I hope you got those answers and you were able to apply what we learned at the beginning. So it's a diameter you're dealing with. Move on to question 2. Angle BAC is 90 degrees. Again, dealing with a diameter. So the angle subtended at angle BAC is 90. And angle ACB is 45 degrees. Okay. And then angle ACD is 45 degrees as well, because ACD, you're dealing with the alternate segment at B, so that angle on the exterior has to be the same. Question 3. And X is equal to 92 degrees because it's double 46, and then Y is 44 when you work it in that isosceles triangle, and then Z is equal to 46. Again, you're dealing with alternate segment, it's 46, so Z has to be 46 because it's the exterior angle for that. Question 4. Angle ABD is 63 degrees. Its angle subtended at the circumference, so it's half of 126. AOD is 126. And we would move on to another slide so you'd understand how you do question 3 and question 4, so as not to confuse you with the working from 1 and 2. And number 3, ADC is 90 degrees. You have to draw that line AD. So once you draw that line, then the angle subtended by that diameter AC has to be 90 degrees. And then number 4, that angle OAD is 27 degrees. Angle OAD. Okay, use the triangle and then you can figure it out once you know it's 90 degrees by D. Okay, question 5, we move on to angle BAC is, again, you're dealing with a diameter, so the angle BAC is 50 degrees because of that, and then angle CAD, that's the angle that would have to be equal to 40 degrees because it's a cyclic triangle, and so that in interior opposite angle is equal to the exterior angle down that line, so those two would be equal. Question 6. Number 1 is 37 degrees, angle OZY. Number 2 is 53 degrees. And number 3 is 106 degrees. And I show you the working for it. You're dealing with a cyclic triangle and you're dealing with a tangent. Okay, question 7. Number 1 is 36. Angle subtended from the same arc. Number 2 is 72. Angle DOA. And again, I worked 1 and 2, and then you would have to look at the other slide for 3 and 4 so as not to confuse you. So the angle in the center is DOA, so that's why it's 72, twice the angle at the circumference. And then I did 3. Angle DEB is 54 and angle OAB is 36. Okay, so I show you the arc that is subtended from and the right angle where you have that triangle there, and then you can work to get that 36 in that isosceles triangle. We move on to number 8. X would be 40 degrees because of that isosceles triangle, and then Y would be 32 degrees in the other isosceles triangle, and then Z would be 116 degrees. That's the angle at the center of that isosceles triangle. Got it? Move on to question 9. Number 1, angle DAB is 63 because it's the angle subtended at the circumference from the same arc, so it's half of 126. And then angle DCB is 117 degrees. ATCB. Why? Cyclic quadrilateral. So the opposite angles are supplementary. So use that fact to get that 117. Question 10, number 1, x is equal to 112. Again, you're dealing with a cyclic quadrilateral. And then y would be equal to 56. And if that's 56, because it's cyclic quadrilateral, z would have to be 124. Then we move on to question 11. RS and RT are tangents to the circle. So if you want to find angle SUT, angle SUT is 70 degrees from the mere fact that the angle there and the 40, they would be supplementary. So once you know that, then you can work it easily. And we move on to question 12. Again, you have the two tangents drawn from a point to a circle, so you have to work out angle SRT. And because of the fact that they're supplementary angles, again, you get it equal to 36 degrees. The angle at R would be 36 degrees. Got it? Okay, thank you for watching, guys, and we'll see you in the next one for the BGCSE examinations. We'll be looking at functions next and showing you how to work those questions that may appear on the BGCSE paper 3. Please like and share, and God bless you. We will see you in the next one. That's a wrap.